Go.
For the majority of the year, we had been treating objects as point particles. However, all objects that are dealt with in most physics problems aren't true point particles, and so we need to treat them that way. We can do this by using calculus to find their moment of inertia. Here is how to find moment of inertia for a rod with the axis of rotation at its center of mass. So, first things first, we want to draw a diagram. We're going to draw the rod. Its axis of rotation is at the center of mass. And then we are going to draw a thin sliver of the rod, which is infinitesimally small. And on the x-axis, we're going to write dx, and in the y, we're going to write dm. So we have this diagram, and the general equation that you start with for finding the moment of inertia is I equals the integral of r squared dm. Now r is the distance from the axis, and dm is the mass of the small sliver of the rod. We can change r to x because it's on the x-axis. So now we cannot integrate for inertia without substituting for dm because we do not want two variables. And we can assume this rod is of uniform density, so we're going to use a density equation to substitute for dm. So this is a long thin rod, so the density equation would be P equals mass over length. And we can substitute for mass and we can substitute for length. Come out density equals dm over dx. And then solving for dm, we get dm equals density times dx. And then we're going to go back in the equation and we are going to substitute p dx for dm. Okay. And we also have to set a limit on this integral, and we're going to choose L over 2 and negative L over 2 because it's split down the middle, and that accounts for the full object. So okay, now we can begin to integrate. So first step, we're going to do I equals density times and then we are multiplying density, so that can be substituted for, and just like we did up here, we can change it to ml. So I equals m over l times x to the third over 3. Okay, then we'll bring it up here, and when you do that, it's m over 3l and then finally simplifying this, we come out with I equals 1 over 12 ml squared, and that is our answer. Now this can change depending on where what the axis of rotation is. So if it was on the end, this would be a whole different number. It would change, and you have to account for that and make sure that you're paying attention, and always draw the diagram first to set things up. And from object to object, this number is going to be different every time. And like I said, draw a diagram, and from there you just use density, and that's pretty much it. And from there you just integrate, and it's pretty simple. Thanks.